Hello, and welcome to this Miliastra Wonderland guide. Today we'll be learning how to make the classic mode game. Attack on Nian Beast. Firstly, we need to understand the game that we're making. In order to do that, let's explore the core gameplay loop. The game begins in the lobby, where players can select buffs and purchase stat upgrades using their starting gold. Once prepared, players enter a level and begin collecting red packets scattered throughout the map. To complete the level, players must offer the collected red packets to the shrine. However, this task is complicated by the Nian Beast, which roams around the map. Players must also keep the beast satisfied by feeding it food found throughout the level. If the Nian Beast becomes too hungry, it will become enraged, transform into its adult form, and begin hunting down and attacking players. To deal with an enraged Nian Beast, players can either feed it to calm it down or use fireworks to attack and temporarily stun it. In addition, players may use their character's skills to damage the beast and protect themselves. Once enough red packets have been offered to the shrine, the escape point is opened and the player needs to search for it around the map. Upon interacting with the escape point, the level is cleared and players return to the lobby, where they can purchase additional upgrades and prepare for the next stage. Now that we've learnt the core gameplay loop, we can start on the editor. Firstly, we'll focus on the stage as it is the most important aspect of the game. Here are the settings used by the stage entity. The stage is responsible for managing stage progression and runtime modifiers across gameplay sessions. It handles how players advance between stages through level progression, as well as how each stage is dynamically affected by random event modifiers. Let's now delve deeper and talk about the node graphs used for the main systems. The stage signal node graph handles what happens whenever a stage is completed or started. It also shows the level system of the stage progression. It is a simple progression system where the Nian Beast will deal higher damage when reaching higher levels by modifying its attack. Other than that, the node graph mainly modifies the environment configurations and modifies some custom variables. Now let's talk about the stage event system. In the stage timer node graph, there is a timer for random events. This timer randomly selects a stage event and applies it to the current stage by modifying the custom variable, stage events. It is then continued in node graph player signal where the player's statistics structures are modified based on the event. These events can be advantageous or disadvantageous to the player, making stages feel different for every run. Moving on is the stage settlement system in the exit settle node graph. This node graph is not on the stage entity and is actually placed on the exit prefab. Here are the settings used by the exit prefab. Most of the settings like nameplates and VFX are mainly used for decorative and UI purposes. For example, the custom variables are updated whenever clearing a stage to showcase how much coins the player has accumulated. It also records and shows the total amount of stages completed. The node graph helps to record information such as player rank score, player settlement scoreboard data display, player settlement success status and others before settling the stage. It also helps to determine if the player has accomplished any achievements. Moving on, we will now focus on the Nian Beast. Here are the settings used by the Nian Beast. It is important to understand that the Nian Beast prefab is only an empty object. The Nian Beast will then create the model based on the mode that it is in. For example, whenever it spawns, it will create the baby Nian Beast model and make the model follow itself. When mode switching, it will destroy the baby body model and create the adult body model. All the settings used also accommodates for both baby and adult models. For example, there are two nameplates for the HP and hunger bars for the Nian Beast. These two bars are for the baby Nian Beast and the adult Nian Beast. That way, it allows for easy switching between modes without completely using a new prefab. However, how these models attach and follow the Nian Beast is also very important. We want the models to have animations so that the Nian Beast doesn't feel stiff. As you can see, in normal gameplay, the Nian Beast constantly flaps its wings and moves its legs when moving. The Nian Beast also opens its mouth when enraged. But how is this possible? The body parts use follow motion device, so how are some body parts able to move individually? This is because we get the help of this little bird right here. This bird has something very special that allows the Nian Beast to have animations, and that is the preset status. When changing the preset status, the bird then has animations of flapping its wings. To replicate this on the Nian Beast, we make the bird follow the Nian Beast empty prefab, and the body part will then follow the wings of the bird. Other animations also follow the same principle, such as the legs, as well as the mouth. Here is the node graph Nian Beast, which contains the model initialization component. It may seem daunting at first, but it is only creating parts and making them follow other parts, as well as inserting them into lists for record purposes. Basically, it is only repeating the same process of creating body parts over and over. Moving on, we will now be talking about the health system of the Nian Beast. The Nian Beast uses a traditional HP value to determine how much damage it can sustain. This value decreases whenever the Nian Beast is successfully hit by player attacks, or when being fed with fireworks. After depleting the Nian Beast's HP, it will stun itself, revert back to its child form and drop a large amount of red packets. However, due to the fact that the Nian Beast is an object, some characters that have auto-targeting abilities like Mavuika's skill or Nahida's lock-on skill do not actually register the Nian Beast as an enemy. Thus, we place a Ruin Guard on the Nian Beast for it to act as the Nian Beast's hitbox. All skills of the Ruin Guard are removed to ensure it stays passive and does not move. Extra collision is also used to ensure the Ruin Guard stays still and does not stray far away from the Nian Beast. Here is the node graph hitbox monster, where it shows how the Ruin Guard acts as the Nian Beast's HP and transfer damage. Moving on, here is node graph hitbox, which demonstrates how the Ruin Guard always stays on the Nian Beast. This is done with collision trigger detection, where if the Ruin Guard were to be detected phasing through the extra collision and leaving the collision trigger, the system will automatically destroy the current instance and spawn a new one in its correct position, ensuring that a valid hitbox is always maintained throughout gameplay. From here, let's take a look at the Nian Beast's hunger and food system. The hunger and food system is one of the core mechanics of the Nian Beast. The Nian Beast will slowly increase its hunger meter and can only be decreased through feeding it with food or fireworks. Once the hunger meter reaches the yellow exclamation mark, the Nian Beast will turn into its adult form and start stalking players. Subsequently, once the hunger meter reaches to the red exclamation mark, the Nian Beast will be enraged and start attacking players. Here is the node graph 01_Nian Beast, which shows the entire hunger system. It uses a timer to slowly increase the hunger meter while taking an account of special statuses like poison and freeze. The following shows the process of feeding the Nian Beast with either food or fireworks. When player selects the feed tab on the Nian Beast, the food will use follow motion to fly towards the Nian Beast's mouth. When the flying items enter the Nian Beast's mouth collision trigger, it detects which item is being fed. Based on the item being fed, the effect differs. For example, feeding food will decrease its hunger, but feeding fireworks will apply special unit statuses or other effects to the Nian Beast. Moving on to 00_movement controller node graph. This is where the Nian Beast handles its anger state changes. When anger level changes, it switches the model of the Nian Beast and toggles the UI of all players. It also switches its movement logic, but that will be explained later in the video. Let's now move on to the movement behavior of the Nian Beast. The Nian Beast is assigned a series of invisible path points placed throughout the map. These path points act as waypoints that guide the Nian Beast's roaming behavior. During normal operation, the Nian Beast continuously travels from one path point to another, creating the illusion that it is patrolling the village in search of food. The following node graph path point controller shows the initialization of the path points where other nearby path points are registered into its custom variable. As mentioned before, the Nian Beast will stalk players when it is in its adult form. It will then switch to attacking the player only when it is in rage. Here is the node graph movement controller, which will be explained in several sections. Firstly, this is the initial setup for the Nian Beast speed. The speed differs based on the current stage level. Moving on is the path point detection and destination logic. It locates available paths points to move to and determines next destination. When stalking, it locates path point that has the shortest distance between itself and the stalked player. Here is the rotation and location movement logic. It uses basic motion device to face and move towards detonation and determines the next course of action after finishing movement. The movement controller node graph also contains the anger level switching logic. This is because when mood changes, the Nian Beast will also change its movement logic. For example, as mentioned before, the Nian Beast will only stalk the player when in adult form and only attack the player after being in rage. Movement controller also contains the player detection logic, which uses collision trigger detection. It changes its movement logic whenever a player enters its collision trigger and whenever they exit it. Finally, there is also a special case that completely halts all movement of the Nian Beast, and that is when being fed with the freeze firework. With the movement mechanics complete, the next step is to implement the Nian Beast's attack patterns. The attack system is only active while the Nian Beast is in its enraged state and has successfully reached a player. The Nian Beast has several attacks, those of which are Control, Fireball, Laser, Stomp, and Bombs. As for how these attacks are executed, we have to take a look at node graph Nian Beast. In here, most functions are based on a timer, attacks are no exception. As you can see, whenever the attack timer is triggered, it first checks whether there is any players in its collision trigger. After successfully confirming there are players to target, it selects a random attack from the pool mentioned before and executes it. Control also starts another timer, Control, and has a small delay before spawning crystals around the players. At the end of each attack, the Nian Beast also spawns bombs that hinder the player's movements. As you may have noticed, one of the attacks is called Control and does not deal damage. Instead, it blocks the player's movement and tries to trap them by spawning crystals around them. Players can escape the Nian Beast's control by either avoiding the crystals or attacking them to break out of it. Here is the node graph block crystal, which is placed on the individual crystals, which shows how the crystals spawn as well as how they take damage. Another one of the Nian Beast's attacks is the fireball, which spawns and launches a homing projectile. The homing projectile actively tracks the targeted player's position, making it one of the Nian Beast's most dangerous ability. The fireball node is very simple and is only used to damage the player hit. The Nian Beast also has a laser attack where it fires a strong beam and slowly tracks the player. This laser attack actually uses two prefab, laser and laser ray. This is because during the time of the release of this game, the creation skill function and ray detection result were not available. Hence the workaround of using a visible laser for on-hit detection, and when detecting a player, spawn an invisible projectile, laser ray, for handling the damage processing. As you can see from node graph laser, once on-hit detection is triggered, spawn another prefab, laser ray. And here is the node for laser ray, which handles detection for damaging the player. The Nian Beast also has a stomp attack that damages all players within a close radius of itself and applies a knockback effect, launching affected players far away from itself. The attack is relatively easy to avoid due to its long charge-up duration. However, it causes players to avoid the Nian Beast and disrupting their ability to deal melee damage for a short period. Here is the node graph stomp, which is fairly simple with only some VFX nodes and the attack system. The bomb attack is a relatively simple ability that is triggered alongside the Nian Beast's other attacks. It is primarily used to apply passive pressure on players by restricting their movement. The number of bombs spawned is influenced by the Nian Beast's current location. If the Nian Beast is positioned near a higher number of path points, there is a greater chance for more bombs to be spawned, increasing overall pressure in that area. Here is the node graph bomb spawner, which shows how bombs get spawned. And here is the node graph bomb, which shows how bombs track the player and deal damage. After covering the Nian Beast systems, we now shift our focus to the player. The player is the main controllable entity and is responsible for interacting with the environment, collecting resources, and surviving against the Nian Beast. This section will cover the player's core systems, including statistics, damage handling, skills, etc. We'll first be talking about the player's health system. The player health system is responsible for handling all forms of damage received by the player. Rather than using a traditional health value, the game uses a heart-based system, where each heart represents a single unit of health. Whenever a player is hit by an enemy attack, the damage system is triggered and one heart is removed from the player's current health. Once the player's remaining hearts reach 0, the player is considered defeated and the stage ends. The damage system is executed using composite nodes, which are called whenever an attack, for example, the fireball hits a player. Here is a quick overview on the composite nodes used for damaging the player. Damage player life, the primary node responsible for coordinating the damage process and calling the relevant subnodes. Attack hits, reduces players' remaining hearts, life, by 1. Entity int, directly changes an entity's customer variable, integer. Player dead checked, checks whether the player's remaining hearts have reached 0 and, if so, executes the stage settlement logic. Remove items, removes and drops any item the player is holding on to and reduces its value by a percentage amount. Let's now talk about the player upgrade system. The player upgrade system provides players with an opportunity to strengthen their character before entering a stage. By spending golds earned through gameplay, players can purchase upgrades in the lobby to improve various attributes and gain advantages during the upcoming run. Since players begin each stage with a limited amount of golds, they must carefully decide which upgrades to purchase. Once a stage is completed, players return to the lobby with their awarded golds where they can purchase additional upgrades before beginning the next stage. Keep in mind that gold is shared across all players, so make sure to spend them wisely. There are two types of player upgrades that the player can purchase: statistics and skills. Statistics provide passive bonuses that directly enhance the player's capabilities throughout the stage. These upgrades can be purchased multiple times to progressively improve the player's performance. There are several types of statistics upgrades, such as carry capacity, increases the number of items the player can carry simultaneously. Endurance, increases the player's stamina, allowing them to sprint for longer periods. Maximum HP, increases the player's maximum number of hearts. Firecracker power, increases the damage dealt by fireworks. And mobility, increases the player's movement speed. Here is the node graph statistics, which shows the initial setup for the statistics shop prefab. It uses dictionaries to determine each shop's details such as name, cost, etc., while mounting each individual VFX. The node graph also shows the process of upgrading stats when bought with sufficient gold. It modifies player stat structures when buying upgrades, and displays a temporary UI, insufficient gold, when not having enough gold. Unlike statistics, skills provide active abilities that can be activated by the player during gameplay. Each skill offers a unique utility and can significantly influence team strategy. In addition, each skill also summons a pet that follows the player, indicating of the current equipped skill. There are several types of skills, such as Edgy, team damage buff, temporarily increases the damage output of nearby teammates. Zippy, movement buff, temporarily increases movement speed. Scouty, show item locations, reveals the locations of items by emitting a light on the items. Guardy, shield, grants temporary protection against incoming attacks. Kami, rage suppression, reduces the Nian Beast's hunger. Here is Node Graph Player button, which shows the usage of active skills. Some skills use unit statuses while others have specific functions like using VFX to emit light. Here is the Node Graph skill pet, which shows the initial setup for the statistics shop prefab. Similarly to statistics, it determines the details of the shop prefab like name, cost, etc. The node graph also shows the unlocking and equipping pet mechanic. Here is the node graph player skill pet, which shows how the pet follows the player using collision trigger, as well as how the pet changes model when switching to another pet. From here, we'll discuss about the character element buff system. Unlike statistics and skills, team buffs are not purchased and are automatically granted according to the number of elemental characters represented within the team. Some of these buffs include: Pyro increases firecracker power. Hydro increases carry capacity. Anemo increases character speed. Electro increases stamina. Dendro increases max health. Cryo, feeding Nian Beast with food reduces additional hunger. Geo, receive additional coins when submitting red packets. These bonuses encourage players to experiment with different team compositions and create synergies between characters. For example, in a team with 1 Hydro, 2 Electro, and 1 Anemo character, the player will receive the following buffs: Carry capacity +3, endurance +6, and mobility +3. The Node Graph Stage Global Timer shows the registration of character elements and applies them to player stats during the initial setup phase. This system utilizes a composite node, return character element, which evaluates the classic character's ID and returns the corresponding element type in string format. Due to limitations in Miliastra's available nodes and functions, this composite node must be manually updated whenever a new character is introduced. Keep in mind that some character IDs return a null string. These character IDs are Ether, Lumine, Mannequin, and Mannequina. This is because these characters have multiple elements that are modifiable through the statue of the 7. Thus, they return null element and do not provide any buffs. From here, we'll now discuss about the items. Items are resources that can be found and collected throughout the map. There are 3 primary item types in the game: red packets, food, and fireworks. Since players have a limited carrying capacity, they must carefully decide which items to prioritize based on the current state of the game. Moving on, we'll now be talking about the item spawning system. The item spawning system ensures that a consistent number of items are available throughout the stage. Rather than filling every spawn point, the system randomly selects only a certain percentage of the available spawners to spawn random items. This ensures that no 2 stages play out exactly the same, preventing players from simply memorizing routes or relying on fixed item spawn patterns. Here is the Node Graph Stage Global Timer, which shows the start game signal triggering when entering the stage. After triggering start game signal, unit tag is added to all valid item spawn points to act as markers for item generation. It also triggers spawn items timer in stage signal to start process of spawning items. Following that, stage timer checks the number of available spawn points and spawns items based on a percentage of the spawners by calling the spawn item composite node. In composite node spawn items, it selects valid spawn points and removes their unit tag to indicate it is currently occupied, then triggers a timer to spawn the appropriate item. In item movement, item respawn logic can be seen. When an item is picked up, adds unit tag back to the spawner, indicating that the spawner is available. Following that, when an item is used or consumed in Nian Beast, spawns another corresponding item at a random available spawner. Up next, we have the item movement and pickup logic. Once an item has been spawned, players can interact with it to carry it around. Before an item is assigned to a player, the system checks whether sufficient inventory space is available. Once successfully collected, the item is linked to the player and transitions into its follow state. From that point onward, it will continuously move toward the player while maintaining a small offset and bounce effect, allowing players to visually track the items they are carrying. Similar to the Nian Beast, items also use a system that uses motion devices to achieve model animations. This system utilizes follow motion devices on different models with preset statuses to create movement animations. For red packets in particular, an aerial explosive prefab is used to handle the floating behavior, while a metal clockwork mechanism prefab is used to achieve the spinning animation. Together, these components create the visual effect of items continuously bouncing and rotating while following the player. An example of the initialization of model animations is shown here in Node Graph Red Packets. Node Graph is placed onto the animation model, aerial explosive, and other animation models, metal clockwork mechanism, are created. Once animation models are created and followed, the actual model, red packets, are created and follow motion devices used. Items can also be picked up for it to be used later. These items use tab for the pickup mechanic. The items then use collision trigger to detect and follow the player around as if the player is carrying them around. The node graph item movement will show the item follow mechanic as well as the pickup mechanic. The item uses collision trigger to detect the player and switch its follow motion device target for the follow mechanic. It uses tab selection to enable the follow motion device for pickup mechanic. As mentioned before, there are 3 types of items in the game. Red packets, the main objective item required to complete a stage. Players must collect and deliver red packets to the shrine in order to progress. Food, used to reduce the Nian Beast's hunger and prevent it from entering its enraged state. Fireworks, used to damage and temporarily disable the Nian Beast, creating opportunities for players to escape or deal additional damage. For red packets, they are closely related to the extraction point as they are used for the exit mechanism. After offering enough red packets, the exit is unlocked and players can leave the stage. The node graph extraction point shows how red packets are offered to the shrine. Whenever a character enters the shrine's collision trigger, it triggers a timer to check for all items that the player is holding. If there are any red packets, they are then submitted into the shrine and coins are then added to their awards. As for food, there is not much difference from firework other than the fact that their values differ based on the type of food produced. On the other hand, there are multiple types of fireworks, all of which does different types of effects to the Nian Beast. In the O3_firework node graph, you can see the animation model initialization as well as the abilities initialization based on the type of firework spawned. Alright, let's jump into the tutorial. The tutorial system is designed to introduce new players to the core mechanics of the game. It guides players through the fundamental gameplay concepts step by step, ensuring they understand how to interact with items, the Nian Beast, and stage objectives before entering the main gameplay loop. Unlike regular stages, the tutorial is located in the lobby and focuses on teaching rather than challenge. Gameplay elements are simplified or presented in a guided format to reduce difficulty and allow players to learn mechanics at a comfortable pace. Instructions are provided throughout the tutorial to explain key actions such as collecting items, using firecrackers, feeding the Nian Beast, and delivering red packets to the shrine. The tutorial also introduces the items and core systems, helping players become familiar with controls and interactions before transitioning into standard stages. Once the tutorial objectives are completed, players are directed back to the main lobby, where they can begin their first full stage run with a clear understanding of the game's mechanics. The Composite Node Tutorial Update updates the tutorial whenever the player accomplishes an objective in the tutorial. This composite node is present in many node graphs in the following order of execution. Tutorial Collider, Item Movement, Player Button, Extraction Point, Nian Beast, and Nian Beast again. Once the player exits the stage through the escape point, the tutorial done signal in node graph escape point is called. The tutorial done signal is used in node graph stage signal where the stage is cleared and reset. Next up is the art section. Here, I'll only be focusing on the visual assets and art style without diving into any of the underlying functionality. However, I'll be breaking it down alongside a full gameplay commentary so you can see how it all fits together. Let's move on to the map layout and aesthetics. First, let's take a look at the main map. It can be divided into the spawn point, the extraction point, the left and right searching zones, and the jumping platforms up above. Scattered randomly across the map are red packets, food, and firecrackers, along with randomized escape points. Given the massive size of the Nian Beast, the terrain had to be wide open to accommodate it. I added some bouncy mushrooms to optimize the player's exploration experience. I've also incorporated richer verticality into the map to give the layout a lot more depth. We have some randomized time slots and weather events in the game, so I've prepared 3 different times of day. Each time slot has a potential for fog to roll in, and I've actually made 2 different levels of fog intensity for each. Next, I'll be using entity groups to show you the step-by-step process of making the map. Finally, we just need to add the gameplay elements, and we're good to go. When players first enter the game, they'll arrive at the lobby. The lobby was designed in a cross shape. It includes the game preparation area and the exit area. Then, on the left and right sides, we have the slots for stat and skill upgrades, with the player spawn point right in the middle. In the preparation area, there's an entrance to the training grounds where you can complete the tutorial. I've also placed some 4-leaf sigils around the area to help players move around quickly. For the decorations, since the theme is Lunar New Year, it's mostly filled with red and gold ornaments and lanterns. And that's pretty much everything to say about that. And here is the quick map making showcase. Next up is the training grounds, which is mainly designed to help players get familiar with the mechanics. It consists of the spawn point, an item display area, and the training field itself. Here, items like red packets, food, firecrackers and escape point will also basically spawn. But these are all set in preset positions. I am also adding 4-leaf sigils around the training field. The item display area provides players with explanations for items and mechanics, while the training grounds are meant for hands-on practice. Per usual, here's a quick showcase of the scene building process. Next is the Nian Beast prefab section. In order to animate him later on, the monster Nian needs to be broken down into separate parts: the limbs, the body, the left and right wings, the tail, the neck, the head, and finally, the mouth. As for the mini Nian Beast, we can keep it simple and just separate the wings. For the prefabs, I'm going to do a quick showcase and list out the materials. Feel free to pause and check them out. Thank you for watching and following this guide. I hope you enjoy the video. Next
Bye
up
bye.
is the